This lesson we'll be looking at the intersection of lines and parabolas. Now there are three different cases of how a line can intersect a parabola. Firstly, we can have 0 points of intersection, so the line actually does not touch the parabola at all, as you can see on this number plane here. Next, we can have 1 point of intersection. Now, when we have a line that touches a parabola at one place, in exactly one place, we call it a tangent. We call that line a tangent. So let's make a note of that. Exactly 1 point of intersection. So the line is called a tangent if it just touches at 1 point, touches the graph at 1 point. The next case is when we have 2 points of intersection. Now, when we have a line that intersects a curve twice, that line is called a secant. So let's make a note of that. Secant. So that's when we have 2 intersection points. Intersects twice. Now, the way we go about solving these intersection points is actually using simultaneous equations. So let's jump straight into an example. Let's solve y equals minus 4 x squared minus x plus 6. So that's our parabola, and then our straight line y equals 3x plus 7. So we've got a parabola and we've got a straight line. If we want to find out where these two graphs intersect, as I said, we solve them simultaneously. So let's substitute this here, so y equals 3x plus 7. Let's substitute that into our first equation. So we'll get 3x plus 7 equals minus 4x squared minus x plus 6. Now with this, we want to rearrange this so that we have an equation equal to 0. And it's often best to make the coefficient of x squared positive. So let's rearrange this so that we get a positive coefficient of x squared, because when you have a positive coefficient of x squared, it can be a little bit easier to factorize. So let's bring that 4x squared over to the other side. 4x squared minus x over to that side will give us plus x, so that'll be 3x plus x gives us 4x, and this 6 over to that side will give us minus 6, so 7 minus 6 plus 1, and that will make it equal to 0. So now we have a quadratic equation which we can solve for x by factorizing. Now let's use PSF. We're looking for a product of 1 times 4, which is 4 because this is a non-monic quadratic. We're looking for a sum of 4, so we want two numbers that multiply to 4 and add to 4. The factors will be 2 and 2, so we can use that to split up this term in the middle. 4x squared plus 2x plus 1 equals 0. Let's factorize by grouping. I'll pair these first two together. They've got a common factor of 2x. That'll be outside 2x plus 1. And these two here, well, they've just got a common factor of 1. So we'll take the 1 out, and that'll be 2x plus 1. And our brackets are the same, which is what we want. So let's keep going with this. We've got a common factor now of 2x plus 1. And then the other bracket will also be 2x plus 1. Now, you may have recognized straight away that this is a perfect square, because what we've got here is in fact just 2x plus 1 all squared, and you may have recognized that up there, but if you didn't, that's fine, and you've gone through and done PSF, that works perfectly fine. So we know 2x plus 1 is equal to 0, so we'll get 2x equals minus 1, so x equals minus a half. Now with this x equals minus a half, we can substitute that into either one of the original equations. So when x equals minus a half, y it's definitely going to be easier to substitute into this linear equation, because then we're not squaring anything. So we've got y equals 3x plus 7. So when x equals minus a half, y equals 3 times minus a half plus 7, which equals minus 3 over 2 plus, I might make that 14 over 2. So y will be equal to 11 over 2. Therefore, the lines intersect, or the solution is x equals minus a half, y equals 11 over 2. So those are the coordinates of the points of intersection. If we were to sketch these two graphs, we'd find that they would meet at the coordinates x equals minus a half, y equals 11 over 2. Now, one more thing that's important to add. Sometimes you might be asked to just determine the number of solutions, or the number of points of intersection of two pairs of equations. And the way we can do that is actually by using the discriminant, which hopefully you're familiar with now. Once we get to the stage of rearranging, having substituted the equation and rearranged it into this form here, so ax squared plus bx plus c equals 0. Once we've got it into that form there, and we simply want to figure out the number of solutions, or the number of intersection points for those equations here, we can use the discriminant. Now, remember, the discriminant is b squared minus 4ac. If we have a discriminant less than 0, we're going to have 0 points of intersection, so that will be this case here. B squared minus 4ac is less than 0. We have 0 points of intersection. If we have 1 point of intersection, we have the discriminant equal to 0, so this will be b squared minus 4ac equals 0. And lastly, you can probably guess, if we have 2 points of intersection, we will have the discriminant greater than 0. So b squared minus 4ac is greater than 0. So once again, once we've rearranged it into this form here, so we've done the substitution and we've rearranged it into ax squared plus bx plus c, we can simply use the discriminant to figure out how many solutions there are.